everyone. Today we delve into a foundational concept in the philosophy and practice of engineering, the engineering design process. At its core, engineering is not merely about applying formulas or following blueprints, it is about solving problems, designing intelligently, and continually improving what we create. The engineering design process, which embodies this spirit. So this process is systematic, meaning it is not left to chance or guesswork. It involves a clearly defined sequence of steps, yet it is also iterative. We return to earlier stages based on what we learn along the way. Think of it not as a straight line, but as a spiral of learning, creating, and refining. So above all, this process is problem focused. That is, we begin with a clear real world need, solution oriented. Our goal is always to deliver value through thoughtful functional design. So by following this structured method, we reduce errors, we increase innovation, and we maximize success. So the first step in any meaningful engineering endeavor is to understand what exactly we are trying to solve. This may sound obvious, but surprisingly often engineers rush to solutions without grasping the problem fully. Instead, we must begin by identifying a specific need. So this could be a societal issue, a mechanical inefficiency, a user complaint, or a technical gap. Next, researching existing solutions. So we learn from what has already been tried, both successful and unsuccessful. Understanding the criteria and constraints. So criteria are the standards the solution must meet: performance, efficiency, aesthetics, durability. Constraints are the limits we must work with: cost, time, regulations, and available materials. So only once we understand all of this, we write a concise problem statement. Okay, and with the problem clearly defined, we now move to one of the most creative parts of the process, that is generating ideas. This is where the mind stretches. No idea is too wild at this stage. We encourage individual brainstorming. So everyone brings their unique ideas. And group brainstorming, so ideas are shared, debated, expanded upon. So it helps us to sketch the diagrams or build simple models. This makes the abstract real and allows for early visualization. Then once we have multiple ideas, the next logical step is to evaluate them and decide which one is worth developing. We use a design matrix. So this is a table where we compare each concept based on multiple criteria like cost, feasibility, performance, and risk. We assign weights to each criterion based on how important they are, then score each idea. So this method, which prevents bias or personal preferences from dominating, it brings logic and transparency to the to design making process. So at the end, we select the concept with the highest score, not just the most exciting one, but the one that makes the most engineering sense. Okay. So now comes the hands-on phase, that is bringing the design to life in the form of a prototype. A prototype is not the final product, it is a preliminary version built to test ideas quickly and cost effectively. So we can use low fidelity prototypes, that is rough sketches, cardboard models, or mockups. So these are fast and cheap, great for initial testing. And then high fidelity prototypes. So these are more detailed functional models made with the final materials or close alternatives. So testing is critical. We don't assume our design is perfect. We evaluate it rigorously, collect data, and iterate. Every failure is feedback. Every flaw is an opportunity for refinement. Right? So the final step is often overlooked but crucial for professional engineering practice: refinement and documentation. Based on the feedback from prototyping, we optimize the design, making it more efficient, user friendly, cost effective. We focus on performance. Does it meet the original criteria? Then we move to thorough documentation. This includes technical drawings, process logs, specifications, test results, and a summary of the entire journey from problem to solution. So this documentation is the legacy of your design. It allows others to replicate it, improve it, or use it as a foundation. So engineering design process is not just a technical method, it is a philosophical commitment to rigor, creativity, and continuous improvement. As future engineers and innovators, your role is not only to build, but to build with purpose, with intelligence, and with humility. So by embracing this process, you're not just solving problems, you are shaping the future. Thank you.